Welcome back to the course on computer network and internet protocols, and in the last week class we are discussing about quality of service in the internet, and we have looked into the basic definition of quality of service and what is meant by quality of service and what are the parameters that impact quality of service, and we have seen that 4 parameters bandwidth, delay, jitter and loss. They have a significant impact on the network quality of service, and whenever we are trying to ensure quality of service over the internet, we need to have a control over these 4 parameters. Now, we look into that what support do we require from the TCP IP network to ensure the quality of service in the network. So, we look into the architecture in details in today's lecture. So, as we are discussing in the last class that based on the quality of service, we can have multiple classes of applications. We can have constant bitrate application. Constant bitrate application means in short form we call it as a kind of CBR application. So, in case of CBR application, you expect the data at a constant bitrate. So, the receiver expects that the data will be coming at a constant bitrate, and then the receiver will process that data and will be able to render that data further. So, the example of constant bitrate requirement QoS requirement is telephone application or this voice over IP application. Say whenever you want to make a VoIP call, you have to transfer the data or the voice data over the IP network. So, whenever you are transferring the voice data over the IP network, the voice is actually converted to a digital signal. The voice signal is digitized, and after digitizing the voice signal, that data need to be transferred at a constant bitrate. Then the second class is real time variable bitrate. So, here the bitrate can be variable, but you need to transfer the data in real time. So, by real time we mean that there is a maximum delay by which you need to send the data. If you fail to send the data by that time, then your data transfer will consider to be failure. So, the example of real time variable bitrate is the video conferencing or live streaming. Then the third class is non real time variable bitrate. So, here you do not need to send the data in real time. You do not have as such strict delay requirement that by within this time you have to transfer the data. Buffering is supported, but you require certain QoS. Still you have a kind of loose delay on the loose bound on the delay or loose bound on the amount of packet loss that can be tolerated, and that is example can be on demand video streaming or IPTV kind of services. And then finally comes to the fourth class of service, which we call as the available bitrate or the best effort service. So, best effort means whatever is the available bandwidth now in the network, you utilize that bandwidth for transferring the data for say file transfer. For file transfer as such, we do not need any strict requirement on the quality of service parameters. You can transfer it with whatever available bandwidth is there in the network. So, that kind of transfer we call it as available bitrate transfer or best effort transfer. So, this is the basic quality of service architecture in the internet. This figure I have taken from a Cisco website, and the link is given here. So, you can see that there are multiple stages in this entire end-to-end pipeline. So, let us explain this figure, and then we will go to the internals of every individual step. So, the packets are moving from one end to another end, and at every individual step we are applying certain filters. Filters means we are actually looking into the property of this packet and taking certain kind of corrective measurement to ensure quality of service in the end-to-end application perspective. So, the first thing is kind of admission control. So, if you remember, whenever we discussed about that what is our expectation from the network to ensure quality of service, one expectation was to find out whether the network can take or whether the network can accept more flows without violating the quality of service of the existing flows. Now, to ensure that, we have the first module, which is called the admission control module. So, what this admission control module does? It basically admit a new flow in the network by ensuring that even if you are admitting this new flow in the network if you know that what is the quality of service requirement for that particular kind of flow. So, this requirement we call it as service level agreement or SLA. So, we will discuss all these terminologies in details later on, just giving you a broad overview, a kind of bird's eye view of the entire system. So, based on this service level agreement, you know that what is the expected QoS level for this particular flow. Now, whenever you are entering this flow in the network, during that time you try to estimate that if you enter this flow in the network, then whether you will be able to satisfy the quality of service for all the existing flows plus this new flow in the same network or not. If you are able to do that, then you admit or allow that new flow to transfer the packet, otherwise you block that flow. So, that particular module is termed as admission control. After the admission control is done, then the next step is classification and marking. So, what this classification module does? The classification module basically identifies the classes of packets which are there. So, as we have discussed that there are 4 different classes of application, they are kind of broad classes. In different network context, you can have much more granular definition of quality of service classes. So, considering those 4 classes of service, the guaranteed bit rate or the constant bit rate, the real time variable bit rate, the non real time variable bit rate and the best effort or available bit rate, you classify and mark the packet that which packet require say constant bit rate, which packet require non real time variable bit rate, which packet require real time variable bit rate and which packet requires this available bit rate. So, basically it does not require any particular bit rate. So, based on that you mark the packet. So, just like a blue packet, a red packet, a green packet or a yellow packet like that, and then go to the next filter, next level of filters. Now, all these filters are actually implemented at all the layer 3 devices, that means inside the router. So, inside the routers we implement all these individual filters that we are currently talking about. So, and the third filters is traffic policies and markdown. So, what traffic policing looks into? Traffic policing looks into that whether certain kind of flows or certain kind of packets in the flows is significantly violating the quality of service requirement or not. If it is violating the quality of service requirement, then you simply drop those packets. So, the idea is there that if you know that well your end to end delay requirement is say 10 millisecond, let me explain it with the help of an example figure. Say your end to end delay requirement is 10 milliseconds. So, you have a host, a source host, then coming to an intermediate router and then there is this destination host, and in between you have an intermediate network. Through 2 different networks they are say connected. Okay. So, in this network now say the end to end delay requirement is 10 milliseconds. So, my end to end delay requirement is 10 millisecond. Now, once so you are sending a particular packet, say you are sending a particular packet from the source, and once this packet reaches to this router, then this router finds out that the packet has say already experienced 9 millisecond of delay. If the packet has already experienced 9 millisecond of delay and this router is very sure that it is impossible to transfer this packet to the destination within 1 millisecond. So, that means if the packet has already experienced a 9 millisecond delay, then within 10 milliseconds you have to send it to the destination. That means within 1 millisecond you have this remaining 1 millisecond, you have to send the packet from this router to the final destination, and the router knows that it is totally impossible. If that is the case, then what the router does, the router simply drops this packet. Why the router drops this packet? The reason is that you know that you will not be able to satisfy the quality of service for this particular packet. If you are not able to satisfy the quality of service, then there is no meaning to send that packet unnecessary to the link, because it will again clog the link, it will take certain bandwidth, it will reach at the final destination, the application again need to process that packet. So, there is a whole lot of overhead which are associated with this entire process. So, if you are sure at an intermediate step that you will not be able to satisfy the quality of service requirement for some specific packets of some specific traffic classes, then you immediately drop those packets. Okay. Coming back to the stages. So, that is called the polishing and markdown. Then the next step is scheduling, where we apply the queuing and the dropping policies. So, scheduling means based on individual requirement of traffic classes, we basically prioritize individual packets. Prioritizing individual packet means, say again let me give you an example. Say your packets are coming to an input link and you have multiple service queues. Okay. So, say this is a red queue, I have a blue queue and I have a say yellow queue. Now, these 3 queues has 3 different priority levels. So, say the red queue has a priority of 1, the blue queue has a priority of 2 and the yellow queue has a priority of 3. So, priority 1 means it is the highest priority and priority 3 means it is the lowest priority. Now, the scheduling works in this way. Say if you are receiving a red packet, then this red packet you put it in the red queue. Okay. So, red packet means say that this is a voice packet. So, red means voice, say voice has the highest priority because we have seen that it has a very strict requirement on delay, jitter and bandwidth. So, say red means voice. So, whenever you are getting a voice packet, you are putting it in the say red queue. Whenever you are getting a blue packet, say this blue packet is assume it is a video packet, the second class of traffic, you are putting it in the blue queue, and whenever you are getting a yellow packet, say yellow packet means data, it is the lowest priority as you have seen. So, whenever you are getting a yellow packet, you are putting it in the yellow queue. Now, here you have the server that will finally serve this individual 3 queues in a round robin fashion, and there you apply this priority queuing mechanism. So, the priority queuing mechanism says that if you have some packets in the red queue, you first transfer those packets. So, this is the first transfer. If the red queue is empty, then only you go to the blue queue and transfer the packets. This is the second priority, and if both the red queue and the blue queues are empty, then you transfer the packets from the yellow queue. So, this is the least priority. So, that way you are ensuring that the voice traffics which are there in the link, they are getting highest priority and they are transmitted first, so that their strict QoS delay requirement gets satisfied. So, this is just an example of different kind of scheduling mechanism. This is not the only scheduling mechanism which is used or which is implemented in the network. So, this is one type of scheduling mechanism which is called priority queuing. There are other kind of queuing mechanism like custom queuing, weighted fair queuing, fair weighted fair queuing and so on. So, we will discuss those in details later on. So, the scheduling means scheduling the packets in different application queues based on or different flow queues based on their QoS requirements. Okay. Then the step which we call as the traffic shaping. So, traffic shaping basically tells that say in a link you are getting the packets. So, traffic shaping actually ensures that smooth jitter in the network, it controls the jitter in the network. Say you are getting the packets at random delay, now you send it to a shaper, the shaper will output the packet at a constant rate. So, you are actually getting the packet at with jitter introduced. So, the shaper will remove the jitter and send it to the outgoing queue. So, that is the objective of the traffic shaper, so that you can regulate the flow of traffic over the outgoing link. So, it is a kind of traffic regulator. And finally, we apply certain link specific mechanism, like if it is a Wi-Fi link, then Wi-Fi has their own QoS service, QoS provisioning service, like prioritizing traffic for link layer channel access and so on. So, these link specific mechanisms are finally applied. So, this is the broad mechanism, broad QoS architecture through which we try to guarantee end-to-end quality of service in the internet. So, we will now look into all these individual steps in little more details. So, let us start with admission control. As we are mentioning that admission control ensures that new flows are entered in the network only if the quality of service of all the existing flows, including the new flow, can be satisfied. So, you have actually experienced this context of admission control. Many of the time, whenever you are dialing over say the cellular network, you have heard this phrase like all lines are busy, please dial after some time. So, whenever you are hearing this voice, that is actually blocking your call, because the cellular service provider, it does not have sufficient amount of resource to ensure the minimum quality of service for your call. So, that is why it is blocking your call, and for long distance call it is pretty common that it will say that all lines are busy, please dial after some time. So, it is like that the network does not allow new flows if all the network resources are blocked in servicing the existing flows based on their quality of service requirement. So, that is the first phase of maintaining quality of service. So, you do not admit a new flow if you cannot support quality of service for all the flows including the new flows. The second mechanism was classification and marking. As I have mentioned, that classifies the packet based on their application QoS requirements and then mark the packets accordingly. So, to classify it, in case of IP, we use a header in the IP header field. It is called the IP type of service. So, we have a 8-bit field, 8-bit type of service field in the IP header. In that type of service field in the IP header, you have 3 bits for IP precedence. So, this IP precedence value, it define different kind of traffic. Say, if the precedence value is 0, then it is a kind of routine packets. Then if the precedence value is 1, it is the highest priority packet. If the precedence value is 2, it is the immediate priority packet. If it is a priority 3, it is a kind of flash packet. If it is priority 4, flash override packet. For 5, a kind of critical packet. For 6, it is inter-network control packets. 7, it is network control packets. So, that way we define these 8 different classes of traffic based on the IP precedence. Then the next 4 bits, it actually defines the priority inside the classes. So, for example, if you want to send voice, video, voice and streaming video simultaneously, you can use it under this critical class, and under the critical class you can again relatively prioritize voice, give more priority to voice over the video traffic. So, that way this 8-bit IP type of service header can be type of service field in the IP header can be utilized to identify or to mark the packet to a specific quality of service class. Now, the third filter which we apply for quality of service, it is polishing and markdown. So, polishing and markdown means monitor the flow characteristics and take appropriate action based on the flow QoS. So, For traffic policing, as we are mentioning initially, that we have a terminology called service level agreement. So, this service level agreement says that you have an agreement or a contract between the customer and the service provider to maintain the quality of service of an application. So, for example, if you want certain quality of service for the VoIP data, for the VoIP data, you have to go for a service level agreement with your service provider. Say if you are purchasing network from Airtel or from say Vodafone, with the service provider, you have to make an agreement that well I want to transfer the VoIP traffic. For that VoIP traffic I require this class of service. So, for that what is the money that I have to pay. So, you have to pay that much of money, and in that case you have a service level agreement or SLA with your service provider. Now, this SLA will determine that how your packets will be treated when the packets are going over the network. Say one interesting example of service level agreement is whenever you are subscribing for say broadband connection. So, whenever you are subscribing for broadband connection, you will see that there are multiple packages. Say you can have 1 Mbps of leased line for 1 month, you can have 256 kbps of leased line for 15 days and so on. So, these packages are kind of service level agreements. So, they are saying that whatever data you will send, for that data we will try to give you 1 Mbps of peak bandwidth or 256 kbps of peak bandwidth. Many of the time you will see that there is a differentiation between the uplink traffic rate and the downlink traffic rate. So, it will say that you can have 256 kbps of uplink rate and say 1 Mbps of downlink rate. All those things are kind of service level agreement that you have with the service provider whenever you are subscribing for a specific package for getting your internet connection. Now, this kind of service level agreements are actually also embedded in the IP packets, and this is one example of configuring service level agreement in a particular router that track 10 IP SLA 11 reachability, and the agreement is delay down 15 up 15. That means, in the downlink it can tolerate up to 15 millisecond delay, in uplink it can also tolerate into up to 50 millisecond of delay. So, this is one service level agreement which has been configured in a particular router. So, I have just taken the trace of a router to show you that this way you can configure the service level agreement in the edge router or the gateway routers of a specific network service provider. So, the network service provider, so whenever you are going for a service level agreement, the network service provider actually writes down all those service level agreement in the network based on their policies, based on their architecture and so on. Now, this traffic policing, it monitors the flow of traffic and mark them to take appropriate action, like whether you want to reduce the priority or whether you want to drop the packets and so on. Okay. Next, the fourth step was traffic scheduling. As we have mentioned that based on the markdown by different traffic policers, the scheduler schedule the traffic into output buffers of an interface. And the example that I was discussing in the terms of priority queue, that you maintain multiple queues at the interface, the scheduling mechanism services the queues based on the scheduling policy. So, one example is the priority queue that I was mentioning. So, on arrival of a packet, you classify the packet and then put it either in the high priority queue or in the low priority queue. If you are in the high priority queue, you will be serviced first compared to a customer at the low priority queue. So, the link will sub it one by one and send the packet in the outgoing link. So, that way you are giving priority to certain classes of traffic which will experience better quality of service compared to others. Finally, the traffic shaping, as you are mentioning, so the traffic shaping control the outgoing traffic rate irrespective of the incoming traffic rate. So, you are always regulating that what is going to be your outgoing traffic rate. So, either it has constant bit rate output from the interface buffer, or you also want certain delay or certain jitter based on the application requirement. So, here is the example of traffic shaping. So, you are having irregulated traffic at the input, and at the output you are getting the regulated traffic, which by the from the figure you can directly see that it is minimizing the jitter in the network. So, outflow traffic has a constant packet rate, so it reduces the jitter in the network. Now, there are these two different terms, the traffic policing and traffic shaping. So, let us look into the difference between traffic policing and traffic shaping. So, traffic policing, what it tries to do, it just looks that whether certain flows or certain packets are violating the QoS service requirements or not. So, you are getting the traffic at this rate and your expected traffic rate is this dotted line. In that case, whatever are the peaks, you just drop those packets. So, this is your traffic policing. So, you see whether something is violating the requirement, if someone is violating the requirement, you drop the packet. In case of traffic shaper, it does something else. The traffic shaper, it actually have this irregulated traffic and it tries to regulate the traffic further. So, you are regulating the traffic at the expected traffic rate. So, this is the difference between traffic policing and traffic shaping. So, we require both in the network, because see, traffic shaping may not always be able to give you a smoothed rate. If your average rate is more than this expected rate, then traffic shaping will not work directly. In that case, you have to apply the traffic polisher to drop the packets which are violating the quality of service requirements, which are violating the service level agreement. Then from the remaining packets where your average rate or your mean traffic rate is less than your expected bound, then you can apply traffic shaper to regulate the output rate. So, remember this difference between traffic shaping and traffic policing. So, this gives you a kind of broad overview of the basic QoS architecture, and in the next class we will go to more deeper inside these three components which are very important from the QoS perspective: the traffic shaping, traffic policing and traffic scheduling. So, we will look into the details of these individual filters that we apply for quality of service. So, thank you all for attending this class.